writing formulae of our compounds, right? So obviously with these topics, right, you do have rules to follow. Rules make it a lot easier for when it is you have to do the actual formula writing. Step number 1, write the symbols for each of the elements. Now you are not going to know the symbols offhand. This is why you have the periodic table, which is given to you guys. I'm going to be showing you all everything step by step for you all to actually see how it's done, right? We are going to determine the valency for each of the elements. Valency deals with the amount of electrons that they have that they could gain, lose, share for bonding to take place. And then we find the lowest whole number ratio because we want the simplest ratio between the valencies. So this table actually will tell us if your element belongs in a certain grouping, what valency they're going to have. All elements in group 1 have the valency of 1. All elements in group 2 have the valency of 2. Transition elements are usually 2, but some elements may have more than 1 valency. When they typically have more than 1 valency, they will tell you in the name which one they want, and you work with that, all right? But other than that, some of them may carry a different valency. Like for example, silver and gold, they carry the valencies of 1, all right? So our transition metals, they can actually vary. Group 3 elements have a valency of 3, 4 has a valency of 4, 5, anything in group 5 has a valency of 3 because that's how much it needs to fill the shell. 6 has a valency of 2, elements in 7 has a valency of 1. Anything in group 8, because that last shell is completely filled, their valency is 0. They're not going to undergo bonding because there is no space on their shells to pick up additional electrons, all right? Are we comfortable with that so far?
Yes, miss.
Boys?
Yes, miss.
So let's put this into some practice now. So let me share my screen. I'm going to put up the whiteboard. So we're going to take them simply one at a time and see how it's done, right? Obviously, we are following our rules. So let's say, for instance, I want to personally write the formula for sodium chloride. I have my rules to follow, right? So let me just pause the share for a bit. I want to pull back up the periodic table because we're going to have to interact with that as well, right? So I want to be able to write the formula of sodium chloride. According to the rules that we were looking at just now, we need to be able to write the symbols first. So we don't know the symbols. We go on to the periodic table and we look for our elements. So we're looking at sodium and chlorine. I believe everybody should be able to see my screen. Sodium. Sodium symbol is Na. Chlorine symbol is Cl. You all seeing that, right? You all saw that just now, right? So we go back now to here and we write it in, right? So sodium was Na and chlorine is Cl. Are you good with that so far?
Yes, miss.
Boys? Christian, Siobhan, Ryan, let me know,
Yes,
right?
miss.
Next thing we have to do now is to determine the valencies. That's what's stated in the rule. Now, to be able to determine the valencies, we need to figure out what groups these elements belong to. So we are using both our periodic table and then that next table that has the valencies. You're going to be using these two things hand in hand, right, with each other to be able to figure it out. This was the reason for me telling you all, print this periodic table, all right? So let's look at where these elements are on the periodic table. So I can see, I'm going to look for it. Sodium is here. This is group 1. Keep that in your mind. Sodium belongs to group 1. I come across here and I find chlorine, and chlorine belongs to group 7. Sodium is 1 and chlorine belongs to group 7. Now we need to go into our next table, which will be our valency table, to be able to determine what valencies we have. Elements in group 1 will have a valency of 1. So sodium have 1 as the valency. Chlorine belongs to group 7 on the periodic table. So the valency of anything in group 7 is 1. Are you guys good with that so far?
Yes, miss.
All right, so we're going back to the whiteboard. I'm going to write down this information. So sodium is 1. I'm going to put that down. Take this step by step. And chlorine is 1. Because chlorine also belongs to group 7, which has a valency of 1. Tell me if you guys are okay with that so far.
Yes, miss.
Right, so I hear from Savannah, Ryan, Christian, and Siobhan. Let me know, right?
Yes, miss.
Nice, like a pie. The other rule now, I think this would be our third rule, is to exchange the valencies. So this is what we mean by exchange. Sodium is going to pick up the valency from chlorine. And chlorine is now going to take the valency from sodium. All right, they exchange their valencies. So sodium again is taking the valency from chlorine. Chlorine is taking the valency from sodium. We write the formula now that we are given. We do not write the ones in the formula because 1 is understood in chemistry. If you didn't have the element, you wouldn't be writing it there in the first place. All right. So the 1 is understood. From 2 go up, we write in the numbers. So the formula for sodium chloride is NaCl. 1 part of sodium to 1 part of chlorine. Questions? Anyone?
Miss, you can explain the part where the ones will come in.
All right. So the reason why we're not putting like a 1 next to the sodium and the 1 next to the chlorine is because it's understood. We know it there, right? If you didn't have an element there, right, we would not write it. So because it's understood, we don't write it in because it would seem redundant. We know it there. It's only the bigger numbers like 2, 3, 4, etc. We write those. But because it's there and we understand that it's there, we don't write it back because we don't want to seem redundant. Good there?
Yes.
Nice. Boys, talk to me. All you good?
Yes, miss.
Let's try another one. There are different types of situations you can get with formula writing. So I want to be able to cover all the bases here today. So let's say, for instance, I tell you, guys, only write the formula for me for magnesium oxide. First things first, I have to follow my rule. I have to go back into my periodic table and I need to determine what is the symbols of magnesium and oxygen. So I come onto the periodic table. Let me resume the share. Magnesium is Mg and oxygen is O. So I go back to my periodic table and I'm going to write it down. Magnesium is Mg. Oxygen is O. Step number 2 is to determine the valencies. So we need to go back to that periodic table, see what groups they are in, then go to our valency table and see what it lines up with. So let's do that. So we are back here into the periodic table and we are going to determine which groups they fall into. Magnesium belongs to group 2. Oxygen belongs to group 6. Magnesium is group 2. I'm saying it again. Oxygen is group 6. So we're going to go on to the valency table now. And we're going to see what valencies correspond to these groups. Grouping table is 2 for magnesium. Magnesium has a valency of 2. I'll say it again. Grouping periodic table is 2. Anything following in group 2 has a valency of 2. Oxygen fell into group 6. It will have the valency of 2. I'll repeat that again. Oxygen was in group 6. It has the valency of 2.
Excuse me, Miss, I have a question.
Tell me.
Okay, so like, how do you get it to the point where you know it's going in group 6?
How I know it going into 6?
Yeah.
Right. So let me show you. So going back onto the periodic table, right? Oxygen is here. Leave the group number here. That's how I know. So you see, when we deal with groups last week, right? Groups were our vertical columns, all right? So when I had introduced the periodic table, I was telling you guys, this line here, that vertical column is the whole group. So this vertical column here is the whole group for 1. This is the whole group for 2. This is the whole group in here for 3. Whole group here for 4. Whole group for 5. Whole group for 6. Yeah, well, it has 6 here, 7. And this is the whole group there for 8. So because I know that this is the whole group, I look at the oxygen, I see what number is on top. It's 6, right? So you have to learn your Roman numerals. That is 6. So I know that that is the number. Good there so far, Savannah?
Yes.
Great. So we go back to the whiteboard with the information that we have. So you guys are seeing the whiteboard, right?
Yes, miss.
All right, good. So magnesium was 2, as the valency said. And oxygen was 2 as well, because the valency of anything in group 6 is 2. The next rule is to exchange valencies. So magnesium takes up this one here from oxygen. And then oxygen takes the valency from magnesium. Now you realize we have some numbers into the mix. So I'm just going to write it the way it should be written. So we have Mg, it pick up at 2. So it becomes Mg2. O for oxygen. And oxygen picked up the 2. Oxygen picked up the 2 there from magnesium. So it becomes Mg2O2. All right? Because magnesium took the valency there from oxygen, and oxygen took the valency there from magnesium. But according to our last rule, they want you to find the simplest whole number ratio between the elements. Now, if I look at the elements and I say, well, you know, you remember doing LCM in primary school where you look for the lowest common multiple? You're more or less doing the same thing here. I look at these two numbers and I say, but I could divide it to something smaller, something simpler, because we're looking for the ratio, the simplest ratio between the two of them. So the LCM between these two numbers will be 2. So I write it down. You all following so far?
Yes, miss.
All right. And now I have to divide the LCM by these numbers. So I say 2 into 2 magnesium, right? It's going to give me 1. And 2 into 2 oxygens is also going to give me 1. So my best formula for magnesium and the advised formula is MgO. That gives me the simplest portion, the simplest ratio between the two elements. Mg is 1 part, oxygen is 1 part. We're looking for that simple whole number ratio. If you come down here and you realize that, hey, the numbers could divide into something smaller, you find the lowest common multiple between these two numbers, you divide by it, and you get a ratio with the simplest portions. We want it simplified as best as we can. So yeah, chemistry does have a little maths into it. Are you all comfortable with this so far?
Yes, miss. Miss, so when you do the LCM of the both and you get the number, you print it after the O.
You don't have anything to put here. In this case, it was 1, so we don't have anything to write in here.
Oh, but like if it was a bigger number, then you
If it
will
was a bigger number, let's say for instance, Mg was 4. I just averaging, right? If Mg was 4 and this was 2, right? I just using two numbers that different, right? Actually, let me write it in. Let's say Mg was Mg4. And now this is not a proper example, but it's just for you to get the division aspect and the placement aspect with the numbers, right? And let me say Mg O is 2, all right? Just a hypothetical scenario, right? The LCM between the two numbers would be 2, right? Lowest common multiple, right? So you divide by 2. So you say 2 into 4 is 2. 2 into 2 is 1. So you would write for me Mg 2 divided by 4 is 2. And then 2 divided by 2 is 1. So you just write your O. Remember, when you're doing your division, your numbers going where it's supposed to be, where you find it originally, not before, not after. Keep it with your element because that is the valency for that element. If you shift the valency and put it in the wrong place, you're giving me the wrong formula. You understand?
Yes, miss.
Good. So let's do one of the examples in the event that you end up with somebody who have more than one valency, right? So I'm going to take an example with lead. Lead has more than one valency, right? So I'm going to use one of the valencies and I'm going to show you that it's going to actually be stated in the name. So let's say, for instance, I'm looking at lead chloride. I am looking at lead chloride and I want to write the formula of lead chloride, right? You see, if they ever give you an example and they have the Roman numeral in the example like this in a bracket and everything, that is the valency. You're using that valency there. You all good? You all got me with that so far?
Yes, miss.
Good. Boys, talk to man, tell man. You all understanding so far?
Yes,
Yes,
miss.
miss.
Right. So lead, according to the periodic table, has a symbol of Pb. And chlorine is Cl. So we write that down first. Establish the valencies, right? Now I just worked one with chlorine, so I know it offhand. Lead's valency is given there. So lead, they want you to work with 2 as the valency. An example up here with chlorine. So chlorine actually has the valency of 1 because it belongs to group 7. All right. So we are good. We're going to switch here. Actually, you're understanding so far, right, son? We're going to, good. We're going to exchange. Lead is going to take this guy here from chlorine. Chlorine is going to take the one from lead. It comes like, you know, when you're in class and all you're sharing food and stuff, right? You switch up, right? You share. So they exchange valencies. So it comes down to become Pb. We don't write anything for 1 because the 1 is understood. Cl2. There is nothing more that could be divided into anything here further. So it's understood. The formula for lead chloride is PbCl2. You guys are good with that? Anybody have any questions?
No, miss.
All right, great. So here's what we're going to do. So I'm stopping the share. I want to be able to give you guys the balance of the information, and then we're going to continue from there, right?